In this video, I'm going to show you all how to solve a matrix equation in your calculator. So we've done them with 2x2 matrices, right? But we haven't done them with anything larger because we haven't been finding inverse by hand of anything larger. So we need our calculator to support us. So as we did when we dealt with 2x2 matrices and we were solving these systems, I'm going to go ahead and I'm going to call this A and this B. Hopefully that makes even more sense now that you've seen it on a calculator, because that's how we're naming them in a calculator, so I can keep it consistent. So what I have and what I'm going to show right now is something that we would expect you to show, right? Like when you're solving 2x2 matrices, you're showing your process. Like we're seeing you find the determinant, do 1 over the determinant times the adjoint, and which side are you multiplying on. I don't need you to, unless you're being asked to write the inverse of A, that doesn't need to happen. So I'm going to go over here, very similar to what we sometimes did with 2x2 even, to keep our work organized. Now I'm going to write my equation. I have AX equals B. My goal is to solve for X, right? So if that's my goal here, I would need to find the inverse of A, and I can't shove it in the middle here. I have to left multiply, meaning that's what I would have to do by B as well. This, as we know, would give us the identity matrix times X equals to A inverse times B. This would give me X. So X is going to be A inverse times B. That is what we want to see. This is you showing your work. The calculator can do the rest, right? And then I can write out what is A. You can get nasty numbers with this stuff because you got your calculator. It's okay. So I went ahead and I took the liberty already to put these into my calculator. So I went to edit and I put them in, and you can see I have 2 3x3 matrices. So I know that I'm doing A inverse times B. So I'm going to recall A first. Oop, I didn't recall it. Second matrix A inverse times B. Second matrix B. When I push enter, this is what I get. As we've talked about before, I'm not rounding decimals right now. You might then be like, I can't see the whole thing. So I'm going to go ahead and push math, enter, enter to convert some stuff to fractions, and that's what I'm going to go ahead and write down. So I've got these nasty numbers, -3, is it a 307, I think, or 387? I think it's a 307. My eyes are a little struggling right now. -857. 238, -29 over 119. 238 is probably the determinant, right? 180 over 119. 104 over 119. And since you have your calculator, and I've showed you in the last 2 videos, I think, or the last 2 parts of this, how you can store this, I'm going to go ahead and store it. Second matrix, let's store it as C. So this will be C, and I'll write that down. And then you know what? I think I'm going to go ahead and I'm going to plug this in and see what happens. Right? Let's do that. So I should be able to, I can check my work. Let's clear this. I should be able to do second matrix A, so number 1, times second matrix C, so number 3. And I should get B over here. Let's see. 7, 3, 2, 1, -1, 0, 14, 23. Got it. Right? So if I really understand my process, I can check my work and let my calculator do the work and then check it. So how you show work when you're solving matrix equations using a calculator is with this process. Okay? Let's look at another, not how you use a computer. Let's look at something else. One of the other things that we can do with matrices is solve a system, which you guys saw a little bit of last week, right? So let's say I had a 3x3 system, 2x plus 4y minus 7z equals 9, -5x plus y plus 3z equals 15, and x minus y plus 10z equals 4. So what I'm going to do for this is I'm going to write this as a matrix equation. So this is going to be my coefficient matrix. These are my x's. My first column are my x's. 4, 1, negative 1. My second column is my y's. My third column is my z's. My variable matrix, I've got x, y, z. You might be wondering, I said these were columns, right? But when you multiply it, picture this, rows by columns, 2x, 4y, negative 7z, right? Equals to, my answer matrix is 9, 15, 4. So just like I did up here, I could go ahead and call this A. That doesn't make any sense. You call this A, I could call this B, and I could call this X. Right? If I'm going to get X, I'm going to be doing A inverse times B. Oh, how did I get that so quick? I have AX equals B. I'm solving for X. I can't shove something in the middle. I have to left multiply. So I have to left multiply over here as well. And that's where I'm getting that AX equals to A inverse times B. And I could go ahead into my calculator, enter these, and do that exact same process, right? And let my calculator do the work and then check it. I want to comment on one other thing that some of you guys will be seeing in a little bit if you choose to learn a little bit more about reduced row echelon, or sorry, no, that's not what it was. It was Gauss-Jordan elimination, which is pretty neat. So I encourage you to maybe watch the video, even if you're not sure if you want to learn more about it. It is something you'll learn eventually, but I could also write this as something called an augmented matrix, meaning I write it all in one matrix. I've got 2, 4, negative 7, and there's this like line here, 9, negative 5, 1, 3, 1, negative 1, 10. Sorry, I've got this 15 and 4. So this is called an augmented matrix, which you might have some familiarity with, or you might have heard that word before. So I wanted to point that out as well. So ultimately, in this piece, I wanted to show you how you would be expected to show work and how you show that thought process, how you can use your calculator to not only solve it, but to check it, as well as how this relates back to systems and another way to solve a system. It could be larger than a 3x3 system. It could be a 2x2 system, right? But this is just another thing that we're adding to our knowledge base so that when you come across different problems or different things in the future, like you have a lot of things that you can pull on and a lot of this background knowledge. It might not always be the best way to solve a system, but it is a way to solve a system, and that is the one that we're focused on right now. So as you have on the last slides, like please make sure when you move on to the next slide that you are doing the practice problems or recording your answers. And then you have one more piece of this lesson where you have a choice of 2 different extension type activities, like further learning, which I encourage you to at least take a look at, even if you're not committing to it, or more practice with this. And I just really want to encourage you to not be afraid of fractions, and to please avoid rounding decimals. We like exact answers, so those can be fractions, unless you need to. Okay, so if a number is irrational for this, you're going to need to round it. So that's okay, I get that, but please don't be afraid of some crazy numbers. So thanks, and if you need to go back and rewatch any of these videos, please feel free to go back and see what you might need help on. Thanks, everyone.